Hi, I would like to talk to you a bit today about Ray film dosimetry software. So these bullet items are the steps I'll describe in further detail about Ray film dosimetry software. After scanning and importing of the film, the interactive calibration can be performed using grayscale or color channel combinations. There are multiple film plan registration methods, as well as 1D, 2D, and 3D comparisons between the film and the dose plane you're analyzing. There are 2D qualitative comparisons, such as isodose lines, dose wash, as well as quantitative comparisons, for example, percent dose difference, distance to agreement, the combination of the two, gamma, and then, of course, we always have reporting to finish up your QA process. So the typical calibration workflow in Ray is similar to that in most film dosimetry software. There is, of course, a defined setup for the acquisition of your film measurements, matching the ion chamber reading configuration as well, so that one can match and select regions in the film over which the average will be assessed, and the absolute calibration in gray can be typed in by the user. Of course, as this is done and as one steps through each piece of film, the calibration curve is automatically populated. And of course, one can see if there are any issues with their calibration as they step through the process. The calibration table can be saved for use with subsequent cases so that you can keep the same calibration for your entire film batch. Registration is the next step. You can use a couple of different methods to do the film plan registration. There's a unique method that's a 3-point option. In this method, one contours reference points into the plan. In Ray, you import the CT, you can import the 3D DICOM dose or dose planes, and then based on the registration in the CT image, as you can see here, the red, green, and blue, then you can match that to points that the user places on the film, and then the registration occurs using this 3-point option. There's also a single point option, and then as well there are translation and rotation tools provided to create a manual registration as well. The previously described mechanism of course can be used, but nonetheless dose normalization can easily be adjusted or scaled within the Ray software. One can view the isodose lines and interactively match those lines using a slider bar in the UI. In this example shown, that the thicker bar is, or isodose line, excuse me, is associated with the plan, and the thinner one with the film measurement. One just can adjust. The plan dose, of course, remains unchanged, and the film dose is the one that is adjusted. As well, one can use circular regions over which an average dose can be calculated for normalization, or a single point normalization is also possible. Additional user adjustable parameters are the dose scaling factor and resolution scaling. Both are applied to the film measurement. The dose scaling factor is useful to correct for non-water equivalent solid plastic water materials, or when measurements are not acquired using the same number of monadic units as the plan, because the resulting dose, for example, would not be within the appropriate calibration range of the film. The resolution scaling shouldn't impact analysis results due to the high resolution of the film, as long as the resolution is not reduced much more than 50%. It's primarily just used to speed up the gamma computation. So after the film plan geometric alignment and any needed dose scaling or normalization is complete, the region of interest must be specified within the software for the evaluation. One can either select a rectangular region or specify a particular isodose line within which the analysis will occur. The user must specify the pass criteria in terms of distance or percent dose difference, as well as percent dose difference. And then based on the reference point, one can go forward and specify or view, shall I say, the percent dose difference for all of the points from the reference point. And the histogram is also visible, so one can get a 2D visual view over the entire dose plane film region, as well as a histogram with the results, as well as dose difference, there's distance to agreement, the combination of the two, as well as gamma. And I'll go into more detail about each of these. For the analysis of the percent dose difference, the equation's pretty straightforward. E sub S is the dose on the film. E sub M is a dose at the same point in the plan matrix. And norm dose is the normalization dose. So in this view, for example, you can see the pink is the positive dose difference areas, the pinks through the reds. The light blues are negative dose differences. Our passing region consists of the two lighter shades of blue and the two lighter shades of pink, with the darker ones being up to plus or minus 9%, and then everything in gray is beyond the plus or minus 9%. But our passing regions are just these four colorations shown here in the histogram. The next analysis is the distance to agreement. So for each of these from a specific point, the measured film dose is searched to locate the nearest point with the same dose value on the evaluated plan dose matrix. This darker green is within 0.5 millimeters. The next shade of green is within 1 millimeter, then out to 1.5, and finally within 3 millimeters of the specified of the region to the location where the dose is located. All the areas in gray are outside of the 3 millimeter range. So for the combination of both the percent dose difference and the distance to agreement, you get this combination where if it's passing in either, it shows in blue in this combined data set. So a pass of within 3% or 3 millimeters. For the gamma analysis, Ray allows for specification of the same criteria. Again, the 3%, 3 millimeters, what's shown here. The gamma analysis is based on the 2003 paper by Lowe. The gamma pass criteria is less than 1 and designated in green in the graphic and the histogram here. Gamma 1 and less than 2 is designated in orange, and gamma from 2 to less than 3 is shown in red, and there are no points beyond a gamma of 3 for this particular analysis. Ray supports the global gamma And this is the well-known table from the 2003 paper by Dan Lowe. Just wanted to point out here that the evaluated dose is the film dose, the reference dose is the planned dose, just for clarity. And so in summary, these bullet items show the basic workflow of the Ray film dosimetry software. And if you have further questions, please don't hesitate to reach out to your local sales representative, and you can find this contact information on our website. Thank you very much for your time. Have a good day.